Quick. 1.1.2, CPU performance. So CPU performance, for all you need to know at GCSE, is three things. It's the three C's. Clock speed, cores, cache. Remember that. So, clock speed is measured in hertz. It's the number of clock cycles per second, so the number of fetch code execute cycles per second. In modern CPUs, it happens billions of times per second, and that's measured in gigahertz, because giga is like billion. So 4 gigahertz is 4 billion fetch execute cycles per second. Right. Second thing, number of cores. A core is like a mini CPU. If you take this diagram here, let's say this is the CPU. I haven't put the cache or the ALU or anything. Core. So that's a four core CPU sort of diagram. And you see they each have their own registers. So it's like a mini CPU inside the CPU. So what that means is that, each one contains their own set of registers, and multiple cores means that multiple programs can be run simultaneously. But you would think a one-core processor or a two-core processor, if you have a four-core processor, that would run at 2x the speed. No, unfortunately, because a lot of programs aren't designed to utilize all four cores. So you don't really need to know this specifically, but when you're making a program, if you want to use all four cores, you have to specifically do that. A lot of programs don't, only use one core, but it doesn't mean that multiple programs can be run simultaneously. So theoretically, up to that many times, of course, performance, but the cache is a temp storage of data, so it's very small and it's temporary, and stores copies of recent data. Like I said in the last video, copies of recent data, because the data you most recently used, you're more likely to use again than the data from some random program running in memory. And yes, it's much quicker than retrieving from RAM, so that's why you do that. It saves a lot of time. So, take us to this exam question here. It's worth 1 mark. You've got computer 1 and computer 2. Computer 1 has a clock speed of 1 gigahertz, a cache size of 2 megabytes, and 4 cores. Computer 2 is 1.4 gigahertz, cache size of again 2 megabytes, but this time only has 2 cores. Now, when running a flight simulator, computer 1 is likely to run faster than computer 2. Using the information in figure 1, identify one reason for this. So it's 1 mark. Okay, so the mark scheme just says it has more cores. Explanation, so let's look. Okay, clock speed. So computer 1 runs faster than computer 2. Now, clock speed is less than computer 2. So that can't be the reason, because it's not going to run faster because it has less clock speed. Cache is the same, so cache has nothing to do with it. But if you look, the number of cores is 4 compared to 2. So in this case, it's running faster because it has more cores, because the number of cores affects the performance of the CPU. Let's take the second question. Explain one reason why the cache size affects performance of the CPU. Now this is 2 marks. So there's 2 routes you can go down with this question. One route, data is transferred faster, which makes the CPU more efficient. Or you could say, it is faster to transfer to and from the cache than transferring to and from RAM. So that's the other way you could go. Both are correct, but either one. But you can't say data is transferred faster than transferring to and from RAM, because it's either or.